Hello once again. So, by now we will be talking about wide area networks. Ano nga ba ang mga wide area networks na available? So, first off, we currently have what we call the dedicated or lease lines, referred to as point-to-point or dedicated connections. Those are pre-established communication path that goes from the CPE to the DC switch and vice versa. So basically, those dedicated lease lines that we have, they cost more. Kasi ang ginagawa ng mga service providers natin dito is that from point A to point B, para ka lang niyang nilagyan ng UTP cable para doon sa dalawang routers mo. Next is what we call circuit switching. So, kailangan ng end-to-end connection established before makapag-transfer tayo ng data. So, gumagamit siya ng mga dial-up modems natin or ISDN. Basically, yung mga analog modems natin nun, those are considered circuit switch network. We also have what we call packet switch. Pwede kang mag-share ng bandwidth with other companies. Yung packet switching natin would only work kung medyo bursty at hindi consistent or continuous yung pag-transfer natin ng information. Some of the examples that we have for packet switch network would be frame relay and X.25. Basically, it can go from 56 kilobits hanggang T3 or to about 45 megabits per second. Now, I'll show you the speed of the networks that we have here. Okay, if you'll be able to notice here, yung frame relay natin, it can go from 56 up to about 1.544 megabits per second, which is what we call a T1 link. Okay, yung T3 link naman natin is 44.736 megabits per second. We also have the E1 link. These are the European standards, yung E1, E3 sa Europe to lumabas. But basically in the US and in the Philippines, we use E1 and E3 technology. So yung E1, E3 natin, 2 megabits siya up to 34 megabits. Meron din tayo ng mga ATM networks. It can go from 155 to 622 megabits per second. And yung mga SONET that can go up to around 159 gig for the transfer. So the physical media, ano ba yung mga ginagamit na handoff ng mga ating mga service provider? Of course, one of them would be the UTP, isa sa pinaka-common. So analog and digital circuits coming into the site from the central office, gumagamit sila ng UTP cabling. Basically, i-hand off sa'yo ng service provider mo yan sa UTP cable, and then ipaplug mo yung either yung switch mo or yung router mo dun sa UTP na yun. Another handoff that we have is coaxial cable. Residential WAN solution, like let's say kunwari yung mga cable internets natin, di ba? Cable internet, yan, coaxial naman ang handoff nila. Pero most of the time kasi dyan is that the service provider would provide you with a cable modem. And then, yung cable modem mo naman, okay, you have a UTP handoff. Papunta naman doon sa either sa access point mo or sa switch mo. Okay? Yan yung ating coaxial cable. Ano yung mga common? One of them is the RG6 cable. Same na ginagamit natin sa mga computer, sa mga TV natin. If you're watching cable TV, that's RG6. Okay? Another handoff that we have would be fiber optic. So, kung high bandwidth siya, tapos medyo malayo, okay? Just high bandwidth alone. Okay? So, basically, fiber optic ang susi sa tagumpay. Ang isang advantage ng fiber optic is that hindi ito susceptible sa electromagnetic interference. Diba? So, yan yung isang kagandahan pagka fiber optic yung ating ginagamit. So, also, there's this technology na tinatawag nating electric power lines. Okay? Electric power lines. Power lines can be attractive candidates to provide internet access to residential locations. Possible siya via the technology na tinatawag nating broadband over power lines. Ang isang advantage kasi nito is that, imagine, kunwari, you're living in the outskirts, like sa province or elsewhere. Those service providers, they don't want to, ayaw na nilang magbukay doon, lagyan ng fiber optic, diba? Kasi nga, most of the time, ilan lang yung available na subscriber natin, di ba? As compared, yung mga power lines natin, basically, nakatayo na yung mga poste na yan. Diba? So kung talagang last mile solution ang kailangan, you could actually use those power lines to provide power. Yan ang isang advantage, especially for those rural areas na parang hindi na feasible dun sa mga telecommunications provider or sa mga service provider natin na maglatag ng fiber optic, okay, or maglagay ng DSLAM doon para sa DSL connection. I can see that electric power lines would be one of the key solutions para doon. Okay. Pagdating naman sa wireless media, of course, our cellular phone technology, di ba? Kunwari yung mga LTE natin, it can go up to 100 megabit on mobile, pero pagka stationary device yan, it can go up to 1 gig. Okay? Basically, they also have this new technology for LTE that can go for more than a gig. So, can be used sa ating mga smartphone to connect the internet. Okay? Ilan yung technologies na available is like the 2D Edge, 2G Edge na medyo mabagal siya. We also have HSRP, medyo okay naman. And of course, we have LTE, which is, it's really fast as compared to the other older technologies that we have. Another way to connect via wireless media are satellites naman. Some locations do not have one connectivity option, such as DSL or cable modems, commonly available in urban areas. However, these locations might be able to connect to the internet to a remote office using satellite communication, where transmission is bounced off a satellite received by a ground station and then sent to its destination. Ang isang disadvantage lang naman pag gagamit tayo ng satellite is that medyo mataas ang latency niya. Pagka satellite kasi, of course, kung may cloud dyan, diba, or umuulan sa area mo, halos hindi ka na rin makasagap ng signal. So that's one of the disadvantages of using this. But nonetheless, if let's say you're living off, like you're currently on the mga mountains and you're planning to build a house there, diba? So this is one of your options para makapag-internet ka pa. Okay. Another option that we have is what we call WiMAX. Yung WiMAX natin na to, wireless technology siya. Definitely, hindi naman, the issue there was that hindi siya compatible sa ating GSM technology. That's why medyo na fell out of favor to versus dun sa LTE. But there are certain there's this certain company like Wi-Fi who provided WiMAX connectivity. Ang kainaman naman sa WiMAX is that pwedeng, of course, yung coverage niya can be the entire city, or ang coverage niya is yung metropolitan area, right? You can that's one of the advantages that we have if we are using WiMAX. Okay. Now, let's talk about HSPA. Yung HSPA naman, technology yan, I believe this is part of 3G. This is 3G technology. Ang speed niya can go up to about 84 megabits per second. Okay. So, next is radio. Of course, you can still use the radio para makapag-transmit ka ng signal. Diba? So, let's say you currently have you have 2 base stations, right? And you need to communicate remotely. Nandyan yung ating microwave. Pwede mong gawin yun. Kung point to point, as long as, ang importante naman doon is that meron kang line of sight, okay, sa other side. So, let's say, kunwari, mga around 2 to 3 kilometers away yung other side mo, you could use a radio, okay, pwede mo siyang itutok dun sa other canopy para makapag-blast ka ng signal. Okay? So basically, yung mga frequency natin is from 3 kHz to 300 GHz. For microwave, I believe they use 2.4 GHz. So you're actually allowed to use it anywhere. Kahit walang lisensya or walang license yung frequency na yun, I mean, since wala siyang license, you could actually use it everywhere. You could, even our microwave ovens, yung mga yung mga cordless phones natin, they're using the same frequency para makapag-init, di ba? And then yung cordless phone, of course, you want cordless. Okay. So, let's talk about, once again, WAN technology. Ano nga ba yung dedicated lease line na yan? Okay, a dedicated lease line is typically a point-to-point connection interconnecting about two sites. So, all the bandwidth on the dedicated lease line is available to those sites. This means that unlike yung mga packet switch connection natin, ang bandwidth ng dedicated lease line, hindi siya pinaghahati-hati sa maraming customers. Iyo yun. So, kung umorder ka ng, let's say, 100 megabit per second lease line, iyo yun for those two sites that you have. Okay? Of course, it comes with a cost. Isa siya sa pinakamahal. But basically, yung mga lease line natin, like let's say you currently have a site in Manila, okay? And then you have a site like, let's say, in Los Angeles, or meron kang site sa New York, right? One of the goal there for the connectivity that you wanted was to get a lease line mula sa isang service provider na makakapag-provide ng connectivity mo dun sa dalawang site ko na yun. Okay? Now, we also have some T1. Okay? Yung T1 natin, originally, ang plano nila dyan was to be used sa mga phones. Okay? Ang goal nila was that magpapasok sila ng isang linya sa opisina. Okay? But you will have, okay, 24 channels do sa linya na yun. Okay, that's a lot, di ba? So, isang linya lang ipapasok ng telco mo, 24 lines na, 24 phone lines na yung pwede mong gamitin. Okay? But eventually, this T1 technology evolved, okay, mas nakilala siya as a data or a WAN technology. Okay? So, for every channel kasi, there's about 64 kilobits, okay? And we call that channel as a BS0. So, yung T1 mo, it has 24 DSOs. Okay? So, and T1 is also called Digital Signal 1. Okay? And yung bandwidth ng T1 circuit natin is around 1.44 megabits per second. Kasi 24 siya, di ba? 24, okay, times 64. So, 64. So, 24 times 64. Roughly around near 1.544 megabits per second siya. Okay? So, that's one of the advantages of using E1. Okay. Next is what we call the E1. Counterpart to, European technology, or sa Europe or elsewhere, they use E1 naman. Okay, so it has 32 channels versus okay, it has 32 versus dun sa 24 channels ng T1 circuit mo. Okay? The advantage there is that, of course, since mas marami siyang channels, mas marami kang multiplier. So, 32 times 64, okay, is greater than 64 kilobits per second times 24, diba? So, mas marami siyang channel, but basically, this is only available sa Europe, and as well as, I believe, in Australia, they're using E1s there as well, okay? But the concern here is that you can only use about 30 channels. Kasi yung 2 channels mo are being used for framing and synchronization naman. But if you have like yung service provider, magpo-provide sila ng equipment sa opisina, also another channel would be lost. That would be for them as well. So around 29 channels na lang yung mga gamit mo dito sa ating E1 link. Okay? Next is T3. So, same T-carrier family. Ang T3 naman natin, it uses about 672 DSOs as compared sa 24 DSO ng T1 mo. So, talagang mabilis siya. Okay? And its bandwidth can go up to about 40, roughly around 45 megabits per second. Okay? Next is what we call the E3 link. Okay? Just as the T3 circuit provide more bandwidth than a T1 circuit, an E3 circuit available bandwidth of 34.4 megabits per second is significantly more compared to sa 2048 bandwidth ng E1 natin. Most common misconception is that the bandwidth of E3 is greater than the bandwidth of T3 because T1's bandwidth is greater than T1, diba? Pero hindi yun yung issue natin. Yung E3 natin, okay, is only 34.4 megabits, whereas yung ating T3 link is 44.7 megabits per second. Pero the issue here is like you're just comparing apples to oranges. Kasi, tulad yan, saan ba available yung mga T1 connection? Sa Pilipinas, di ba? But you can't get any E1 or E3 connection sa Philippines. So, it's like comparing apples and oranges when it comes to this scenario that we have. Oh, ano lang, pabilisan lang sila. Pero nonetheless, you won't be able I'll choose E3 para dito sa site ko na to. Kasi ang offering ng E3, E3, E1, T1, T3 is totally geographic. Okay? Next is the CSU and the DSU. Ito yung ating mga um, digital modems. Okay? If you hear the term CSU, DSU, those are digital modems. So let me just read this slide. Although far less popular than they once were, analog modems allow a phone line to come into a home or business and terminate on analog modems, which provide data connections for devices such as yung mga PCs natin. This analog modem supported a single data conversion per modem. Single conversation per modem. Okay? Ngayon, pag sinabing single data conversation, alright, of course, hindi naman multi-channel yung mga phone lines natin eh. Okay? It is when you have DSL, pero ang phone line natin, kunwari, basic phone line lang siya. Single channel siya considered. Okay, kaya nga, pag kunwari, way back when, if you're using an analog modem, you can just simply either call or you use the internet, 'di ba? Yun ang ating isang dilemma mo dati. If you have if you're using analog modems as compared dun sa ating mga DSL, okay? And as well as dun sa T1, E1, T3 or E3. Kasi nga yung isang linyang ipapasok sa it has multiple channels on it. Okay? Kaya kailangan mo ng isang what we call a digital modem to handle it. Okay? As opposed to sa mga ating dial-up which uses analog modem. Basically, yung CSU and DSU natin, it only works with bits and it's also considered as a layer 1 device. Okay? Yan ang isang advantage ng ating or ang isang feature ng CSU DSU. Layer 1 device siya, so wino-work on niya lang doon sa bits. Okay. So next is what we call a multi-link interface. So yung PPP natin, pwede siyang multi-link. Okay, basically ano nga ba itsura ng multi-link? Alright. So let's say you're currently you have this service provider right over here, okay? And then meron kang like let's say you currently have like three routers in place here, alright? And then you have one line for DSL, or you have 3 lines for DSL and 3 routers for it, okay? Okay, so what would happen here is that these links that we have here will be bonded together. Para siyang isang, kunwari, you have, this one is 1 megabit per second, this one is 1 megabit as well, and this one is 1 megabit as well. So, pero meron kang up and down speed of about 3 megabits up and down. So, ang total throughput mo is around 6 megabits per second. Pwede siyang mag-load balance, and ang isang kainaman sa kanya is resilient siya. Kasi let's say, makat yung isang line mo, you still have 2 up and running. Yan ang isang advantage of our multi-link interface. Ngayon, we have this what we call the authentication protocol. We call it the challenge handshake authentication protocol. Okay, perform ito ng one-way authentication. Okay, yung authentication na yun performs a 3-way handshake. So you have the challenge, nag-response siya sa challenge mo, and acceptance message between a server and a client. Basically, mas magandang gumamit ng CHAP, okay, as compared to its other counterpart na PAP. Kasi yung PAP natin, Pag nag-send siya ng password, it's actually on clear text. So over the line, pop yung ginagamit mo. So it's being sent in clear text, which is totally no-no talaga siya. Diba? Okay. So another thing about it is that what we call the PPPoE or point-to-point protocol over the Ethernet. Okay, commonly used between a DSL modem at home or business and your service provider. Yung PPPoE, encapsulate niya yung PPP frames within do sa ating Ethernet frames. Ang isang purpose ng PPPoE natin is that, let's say kunwari, meron kang router, okay, sa iyong bahay, alright, and then you will be dialing in um, sa iyong service provider. Yung router mo, yung router mo na to, okay, it would have a PPP dialer, okay? And that PPP dialer will provide you, the PPP dialer will have a username, will have a password on it, para makapag-carry over siya ng mga PPP frames natin. And then, kung si service provider mo, meron siyang radio server, okay? Radio server para dun mag-authenticate yung PPP dialer mo. So, ang gagawin niya dyan is that i-allow niya muna yung connection pagka nag-dial in ka, papunta doon sa radio server niya. Okay? Pag hindi ka in-authenticate ng radios, hindi ka makapag-internet. Pero pag in-authenticate ka ng radios, ayun na, Facebook na. Okay? Next is what we call the Microsoft RAS. Basically, this technology is being used sa mga servers ng Microsoft. Like, let's say you wanted to use them as your, you want them to use as your VPN server, okay? Pwede kang gumamit ng Microsoft routing and remote access server. So, basically, kunwari, of course, ito yung internet natin, okay? And you're currently at home, okay? Ang gusto mong ma-achieve was that, of course, since you're currently at home, okay, mag-VPN ka papuntang office, right? Okay, so pass mo yung information mo. And then, pumasok dun sa RAS server ng Microsoft, right? So, what would happen here is that gagawan kanya ng parang tunnel, okay, papunta dun sa network niyo sa office so that you'll be able to use the resources that you have to sa opisina. The advantage of that is that yung tunnel mo na yan is ultra secure kasi syempre napaka-unsecure ng ating internet. Napaka-confidential ng mga information ng companies and we don't want anyone to be picking at our information lalo na pagka nagka-traverse siya ng ating ng internet. So Microsoft, they have this itong remote and routing and remote access server to become the VPN server. May counterpart nito sa ibang operating system. Like in Linux, they have OpenVPN para gawin mo siyang VPN server mo naman. So you could dial in and you could access the information from there. Next is what we call the MPLS. Okay, so it emulates the properties of a circuit switch network over packet switch network. It tags or labels, imposes tags or labels to forward the packets. Labels are assigned to on the edge network and inside base on the label. So paano nangyayari yan? So kunwari, meron kang site, like let's say this is one of your site, right? So ito si host, okay? Tapos si host gusto niyang ma-reach yung other site niyo dito. Kasi nandito yung server, right? So, yung mga telco companies, they have an MPLS network. So, pagpasok ng packet mo dyan, here, right, wala pa siyang tag. Wala pa siyang lalagyan ng label. But once it comes in of this is the edge router that we have here. Pagpasok niya ng edge router, lalagyan na yan ng tag or ng label. So that, pagpunta doon sa switching point natin dito, nandiyan pa rin yung tag mo. At makaka-exit siya where it wanted to go or so kung saan mo kailangan pumunta. Now, pagpasok niya ng other edge network here, tinatanggal niya na yung tagging kasi hindi na naman na kailangan yun since papunta ka na naman doon sa CPE, right? I mean, that's the destination. Pero if you are within the MPLS network, kailangan natin yung tagging na yan kasi maraming customers ang gumagamit ng MPLS. Okay? And for your information to be routed properly, kailangan natin ng tagging. Okay? Para mai-forward siya. Also, ang MPLS natin, hindi na siya gumagamit ng routing table to forward since this technology is actually what we call layer 2.5. Okay? So, hindi siya gumagamit ng routing protocol. Instead, may mga lookup tables siya na doon niya hahanapin yung tag and then forward it accordingly. Okay? That's our MPLS. Now, we also have isa sa pinaka-sikat din na technology, yung tinatawag nating Metro Ethernet. Okay? Based on Ethernet standards that connect customers to the network and the Internet. It uses MPLS. Okay? Yung gitna niyang network, itong network natin na to right in the very middle, it uses MPLS din. Okay? In the ISP providing Ethernet or fiber cable sa ating mga customer as a connection. So let's say you currently have multiple offices around, let's say, the Philippines. Okay? So, kailangan mo ng link sa data center mo. So, basically, yung mga offices mo, they could just use the Metro E, okay? I-hand up sa'yo ng service provider mo yan with an Ethernet cable. You just have to plug in your device there. Ilang isang advantage of using Metro Ethernet. Kasi hindi na parang yung ibang handoff like T1 o ito ibibigay ko sa'yo, bibigyan kita ng DCE device. Diba? So, hassle naman yun. Like, let's say, yung router mo hindi supported ng DCE, you still need to purchase a weak card para ma-handle niya yung DCE device na yun. Okay? Pag Metro Ethernet, what happens is that your provider would be handing down a switch on site. Okay? Ikaw ang gagawin mo lang is that meron silang i-hand off na UTP, you plug it into your router. Okay? And then everyone else here would get connected already. Also, yung ibang service providers as well, they offer yung internet, okay, pwede ka nang dumaan through MPLS. Instead of, you still have to, kunwari, on this location, diba? So, Office 1, may gusto mag-internet. On some implementation, they still go to the head office, and then, pagpasok ng head office, tsaka pa lang mapupunta ng internet. But some service providers, instead of doing that, what they do is they offer it straight. Okay, they have firewalls in place. Like, kunwari sa data center nila, pwede kang mag-collocate ng firewall doon. And then, that's connected to your MPLS. Okay? So, meron siyang private network side. Okay, yung LAN side niya. And then, it also has a WAN side. Yun yung internet connectivity. Ang advantages nun is that, since naka-follow na siya doon sa service provider mo, sureable yan. Yung hindi siya magda-down. Okay, unless, of course, there's a failure on the equipment. Another advantage that you have there is that yung speed of connectivity mo would be extremely fast kasi hindi niya na kailangan padaanin pa doon sa head office. Okay? Instead, nandun na siya kagad, may LAN facing na siya, facing your MPLS network, and the other one facing yung ating internet. Okay? Another technology that we have here is something called VSAT, or Very Small Aperture Terminal. So, used for locations geographically spread out. Uses two-way satellite ground station with dishes. Okay, connects two satellite in geosynchronous orbit. So, basically, if let's say you currently have a site here, okay, dalawa yung meron kang branch office and meron kang yung head office mo, biglang nagkaroon ng failure sa LAN natin, diba? So, paano tayo makakapag-connect? Okay? One of the method that we have here is we could use VSAT, okay? Yung satellite dish mo, siya magbablast dun sa satellite, and then the satellite over here would be blasting it over to sa mga remote sites mo. This would be perfect. So, let's say, in times of war, diba, sira yung mga infrastructure, like in Iraq, diba? Wala silang infrastructure there. So, anong gagawin natin kung walang infrastructure? What can be done instead is that we could actually use itong ating VSAT for us to be able to communicate. So let's say, kunwari, you have multiple camps in Iraq, right? So let's say nasa Baghdad siya, and then the other site is elsewhere. The other camp is elsewhere. So you could use satellite here, okay, to blast information, yung mga briefing natin or video conferencing. You could use a two-way. You could use a satellite to do it. Okay, kasi wala ka pang infrastructure or the infrastructure was destroyed. Okay? So the next thing about it is that we have the cellular and 3G card. Okay, kung mapapansin nyo dito, okay, so meron siyang SIM card, pwede mo siyang pasukan dyan. Okay, tapos itong with card natin na to, pwede mo siyang i-plug dun sa mga routers natin. Pwede mo siyang i-plug dun, okay? Basically, applicable to dun sa mga, let's say, yung mga site mo na kailangan mo nang i-up, pero wala ka pang provision, di ba? Let's say, kailangan na yung branch natin, kailangan nang i-up dun. Pero hindi pa nakakapag-deliver yung service provider ng linya. Okay? For the interim, you could use this technology. Okay? Pwede kang gumamit ng ganitong technology para masolusyonan yun na yung branch site nyo, okay, magkaroon ng connectivity dun sa other sites mo like Fed Office and elsewhere. But this is not actually a long-term solution because ang isang issue dito is that most of the time, yung mga server rooms natin, located siya underneath the ground, right? And underneath the ground, ang hirap ng signal ng cellphone. Diba? Imagine mo nga, kunwari nasa car park ka lang eh. Pumunta ka lang like, kunwari, underground. Diba? Minsan napakahina na ng signal. So, ang hirap ang hirap nang gamitin ng 3G natin. What more if, let's say, kunwari, your server room is like five floors underneath the ground or 6 floors underneath the ground. Hindi talaga ganun ka-viable na ganito yung solution na ma-provide sa atin. Okay? Instead, we can opt for a different solution. Okay? But nonetheless, kunwari mga small offices lang or like remote office siya na kailangan na talaga ng connectivity at wala na kayong maisip, you could actually use itong ating mga 3G cards. Or merong mga routers that they have a SIM card on the inside right away, you could use that and then for your sites to be able to connect agad sa ating head office. Next is what we call ISDN or Integrated Service Digital Network, ISDN. So ang kailangan sa ISDN is that you can have a telephone and data at the same time. Okay? Yan ang isang maganda. Kasi, ang advantage is that you could actually use your, similar ang technology na to, similar siya sa DSL. Kasi way back when, we have analog modems lang, and I mean, using on the phone line, di ba? Ang concern natin doon was that, either you'll use it to go to the internet, or you'll just try to, you'll just use the phone instead. Okay? So, ang ISDN, ang isang advantage is that mas mabilis siya than the standard analog, which is it goes only to about 56 kilobits per second. Pero pag ISDN way back, it's about 64 kilobits. It can go as high as 128 kilobits per second, depende dun sa linya mo. Also, while you're using yung data, okay, you can still use your phone. Pwede ka pa rin gumamit ng phone mo naman, okay? Yan ang isang advantage of ISDN versus sa ating mga analog links. Ang kailangan naman dito is that pwede mo siyang gawing backup. Kunwari, sa frame relay mo or T1 connection mo, pagka nag-fail, diba? At least, andito yung ISDN to back those up. Right? So, now, let's talk about yung ating frame relay technology. Okay, so yung frame relay, it was invented around 1990s. Mas maganda yung performance niya versus dun sa X25. Ang isang advantage is that it's actually cost effective, okay, versus dun sa mga dedicated links natin. Kasi ang mga dedicated links, they're so costly. Okay? So, sobrang cost prohibitive eh. Pero of course, kailangan nating i-link up yung ating mga sites, di ba? And for us to be able to do that, we need ISDN for it. Okay? So, ang issue natin dyan is that, I mean, ang issue natin, pagka dedicated, like on this example that we have here, kunwari, dedicated links sila, di ba? Alright? Imagine you need to have a mesh para meron kang full site connectivity for those links, right? But with ISDN, okay, you don't really have to do that. Okay, hindi natin kailangan gawin 'yon. Okay? Um Hindi natin kailangan gawin 'yon. Instead, meron kang frame relay switch right in the very middle that would do the switching para do sa network natin dito. So, kunwari, para makapag-link up sila together, right, they have the DLC. So, here, okay, yung DLC 103 niya would be connected to DLC 301. So, you just have to indicate it there na, yung DLC 301, locally significant yung DLC na yan. Kasi ibibigay sa yan ng service provider mo. Okay? And you don't really have to know kung ano yung DLC ng other sites. Okay? Para kang ano yan, para kang sumakay sa like sa aeroplano, di ba? Sasakay ka ng aeroplano, pupunta ka let's say sa Japan. So alam mo dito, na ang terminal na kailangan mo sakyan, ang terminal na kailangan mo puntahan would be terminal like Terminal 1. Pupunta ka ng Terminal 1, right? So pagsakay mo pagpunta mo ng Terminal 1, sasakay ka ng aeroplano, okay? Pagdating sa Japan, you don't really have to care kung anong terminal yun, di ba? Nasa Japan ka rin, alright? So, the same as true with our DLCs. Hindi mo kailangang alamin kung ano yung terminal mo doon sa other end. Okay? Hindi siya masyadong importante. Ang importante lang sa kanya is that alam mo kung saan ka dapat sasakay. So, alam mo yung local na DLC mo for it to be able to work. Okay? Next is some of the terminologies that we have for WAN. Okay? This is what we call the local loop. Alright? Yan yung link mo between the central office papunta dun sa iyong CPE on-site. Okay? Now, we have the demarcation point here. Depende ito Yan demarcation point na yan. Kung sa customer, yung kanya yung CPE, okay, the demarcation point would be right over here. Okay? So, ang responsibility to, okay, ng service provider, okay, ito ang responsibility mo. Yan ang purpose ng demarcation. So, kunwari, napagana ni provider itong digital modem, na tools niya gumagana, tapos hindi gumana sa CPE mo, hindi yan problema yun. Problema natin yun, or problema mo yun. Okay? Pero, pag yung CSU hindi gumagana, okay, nag-test siya, hindi gumana, nag-test siya dito, hindi gumana, problema ng service provider natin yun. Okay? Now, let's talk about some of the bandwidth. Let's just go back. Okay? So, yung DS0 natin, it's 64 kilobits per second. T1 has 24 DSO, so it's roughly around 1.5.44 megabits. So, sa Europe, okay, equivalent siya ng T1, so comprised of 30 DS0 circuits. T3 or DS3 comprises of 28 DS1s, okay, 28 T1s. Okay. Next is optical carrier 3 or optical, OC is optical carrier, uses fiber, can go up to about 155 megabits per second. Tapos, yung OC12 natin bundles for OC3, so that would give you around 600 megabits. Okay? So, ang OC48 naman would give you around 2.4 gigabits of bandwidth. Okay? 2.4 gigabits per second na bandwidth naman natin. Okay. So, we already talked about this, yung ating WAN connection types, dedicated or leased line. We have the circuit switch. We also have the packet switch. Now, i-demonstrate ko lang sa inyo kung ano yung itsura niya. Okay? So, what we have here is a dedicated leased line. Okay? So, basically, para lang siyang isang linya. So, parang ang ginawa ng service provider mo is that bumili siya ng RJ45 cable, pinlag niya doon sa router mo, site A, pinlag naman niya doon sa router mo on site B. Okay? But, with the circuit switch network, yung provider mo would use a cloud right in the middle. Meron siyang frame relay switch at the end. So, hindi na masyadong transparent sa atin yun kung paano dumadaan yung information natin dito basically sa gitna. Okay? As long as you're able to reach those sites, it doesn't really matter. Same as true with our packet switch network. So, yung service provider mo, hindi masyadong transparent sa atin yung cloud nila. Okay? But it does the job. Okay? So, site A would be able to connect sa ating site B. Basically, ito yung itsura natin, yung broadband access natin using either cable or DSL connection. This technology that we have here, yung sa gitna niya, kung ano yung nandyan, hindi na natin alam. Pero, of course, may background ako dito sa DSL, so I actually know what we currently have here in the very middle. So, this one in the middle, yung service provider mo, meron siyang DSLAM dyan. Okay? So, this modem that you have here connected din sa DSLAM. Yung DSLAM ngayon, it has a splitter. The other one would go to the voice switch. Okay? Para may phone calls ka pa rin. But the other connection that you would have, okay, it would go to dun sa kanyang mga switches na para makapag-switch na siya. So, yung data mo, mapupunta siya sa isang switch and then eventually mapupunta siya sa isang router. Okay? Yung router ng service provider natin. Now, what about cable internet? Okay, so yung cable network naman natin, it uses this what we call HFC or hybrid fiber coaxial. Tapos, mag-terminate yan sa isang node. Okay, yung node naman yan, okay, yung mula dun sa node, papunta sa bahay natin, basically, it uses coaxial cable. Hindi sila gumagamit ng fiber technology dyan. It uses coaxial cable, and then, yung coaxial niya, okay, connected yun sa iyong cable modem. So, DOCSIS is data over cable service interface specification. Cable modems and like devices have to measure up to sa kanilang standard. Meron din tayong tinatawag na head-end, okay, which is yung central office ng iyong cable provider. So, dyan naman nagte-terminate yung data mula bahay mo papunta dun sa head office nila. Okay, now let's talk about DSL or Digital Subscriber Line, technologies used by telephone companies to deliver services such as high-speed data over twisted pair, copper telephone wires, has lower data carrying capacity than fiber networks. Speeds and quality are limited in range by line lengths. DSL is not a complete end-to-end solution, but rather a physical layer transmission technology. So yung DSL natin, physical layer technology siya. Pero of course, due to branding and everything, parang nagiging collective na term na siya dun sa mga susunod na mga technologies niya, diba? Like PPPoE, we use PPPoE on DSL, pero hindi na natin binabanggit yun. Yung mga linya na yan, we just simply call it DSL, that's it, right? So, tingnan natin ang itsura ng diagram ng DSL. So here, okay, currently, so sa bahay mo, you have this you have this ADSL router, okay, technical terminology sa kanya is what we call the ATUR, which is ATU remote, okay, or ADSL transmission unit remote. We also have on your sa central office natin, we have an ATUC or ADSL transmission unit central. Basically, yung ATUC is one of the ports that you have sa DSLAM. Yung DSLAM natin, it has a lot of ports para makapag-connect yung mga customers ng service provider. Basically, you also have the local loop. So, that's the link between the central office papunta sa house mo. That is our local loop. So, we have multiple DSL technologies, okay? But some of the most common would be symmetrical, which is yung both up and down mo will have the equal speed. Okay? Meron din tayong asymmetric. Yung pababa mo, mas mataas, pero yung up mo, mas kaunti. Okay? So, yan yung ating mga technologies na available sa WAN connectivity. So, I'll be ending the session. For this, if you have any questions, just provide an email to mamadbelrosario@gmail.com. You have a good day. Bye.